Hi friends, if you're watching this video, then I'm damn sure that you must have heard of the term descriptive statistics around which this particular lecture is centered around. Suppose you are given a question to answer what is the average income of India. Another question, you need to answer what is the average expression value of a gene across cancer and across healthy conditions. Right? You need to answer what is the standard deviation of a particular gene expression value across the samples, right? All these different kind of the questions are answered with the help of the field known as the descriptive statistics, where we are trying to do what? Simply we are trying to summarize the data. We are trying to understand the properties of the data at the statistical level, right? So descriptive statistics is nothing but simply it is a tool, or it's a combination of the different kind of the metrics which help us to understand the data at a summary level, right? Now let me explain this concept with the help of one example. So fine, great. So now see here, guys. Like suppose that you are given this particular course like data. Okay, so here I have given a screenshot of the data here right now, and the data is having total approx 10 genes. Okay, and you are given their different samples. Okay, and now you are given a question that what can you do with this data, right? So in order to answer this, we definitely like this we cannot do anything, right? But if somehow we can report the mean of these genes, if we can answer how is the genes distributed around the mean, what is the minimum value of the gene, what is the maximum value of the gene, these are the different kind of the questions that we can definitely answer. Okay, and now suppose that these 20 samples which are given to us, suppose these 20 samples comes from two different conditions, condition A and condition B, then we can definitely compare the mean across these two conditions as well, right? And then we can answer that this particular gene is more expressed in condition A as compared to condition B, right? We can also answer what is the standard deviation of this particular gene in condition A and condition B, right? These are the different kind of the questions to which answer we need the field known as the descriptive statistics, guys. Okay, so let me show you. See, so like we designed a function in R here, and with the help of that, we are reporting here the gene name and the mean of these genes, right? So for example, this gene, we are showing the average expression value of this gene as 4.61 and the standard deviation as 0.68. Similarly, when we talk about this particular gene AAK1, the mean value is 12.12 and the standard deviation is 0.54. Right? Now, definitely we can understand here the data at a much better level, right? Now, suppose you need to visualize this information. Okay, so how can you visualize that, right? So see, here I've given the density plot of this particular data. Okay, and here I've shown just only 5 of these particular 20 genes. And now, based upon this, you can definitely get idea, right? Get idea that which are the genes having maximum standard deviation, which are the genes having all the values present around particular mean value, right? If you know about the density plot and all, then we know that the bump, like the peak is around the mean, basically mean and the mode value, right? So this particular value, this particular gene, the green one, has a mean value of approx 2 point something, right? So near to 3. Similarly, this particular gene has a mean value near to approx 8, right? Approx 7 or like 7.5 something. And we can clearly see that the dispersion is very less around the mean here for this particular gene, where the dispersion for this particular gene is very high, right? And this information is being given by this particular metric, right? So in the field, in the domain of descriptive statistics, we try to answer such kind of the questions, right? But again, the question is, we can answer such questions, not a big problem, right? But we need to have the data. Okay, so now let me give you a few of the examples, like what are the different kind of the data and from where can we find such data sets in the field of biomedical sciences, right? So see here, like here I'm talking about statistics in healthcare and bioinformatics, right? And these are few of the different kind of the data sets that we come across in our day-to-day life if you are bioinformatician. For example, disease prevalence, risk factor analysis, epidemiological data, drug absorption and distribution, right? Where we study about the pharmacokinetics, pharmacodynamics, pharmacogenomics and all. Then we have proteomics data where we try to understand, like study about the protein informations and all. Genomics where we try to understand what is the genetic makeup of a particular organism, right? How the genomics is regulating the different phenotypic characters and all, right? Health informatics, absolutely, right? Like health data mining, EHR data, clinical trials data. A particular drug is being designed, but before coming to the market, we need to perform clinical trial analysis in order to evaluate its toxicity, right, and its safety values. Okay, so for that we have the clinical trials data available to us. Population health studies, undoubtedly, we need to understand what is the frequency of a particular disease in the population. Okay, how is a particular gene is present in the different complete population, right? What is allele frequency and all, right? So for that, we need to have the population health study data, where we have cohort studies, system biology informations. Okay, like when we talk about the cohort studies, do you know which is the world's biggest cohort study prepared so far? Right? I will try to answer you in the coming like time. Then medical imaging data. We go for the different scanning, CT scan, MRI scan, X-ray and all. And we get the image data from there, right? And from there, we can definitely perform image segmentation and different kind of the analysis, right? Let me give you a few of the example, like websites from where we can find these data sets. For example, statistics in healthcare and bioinformatics, disease prevalence. Okay, so disease information data you can find from the website Global Health Observatory. Okay, so you can go to this particular website of WHO, World Health Organization, guys, and go and explore the complete different kind of the information. Like it has having air pollution data, AMR data, assisted technology, child mortality, and a number of different kind of the informations. Okay, then we have risk factor analysis, epidemiological data, right? Like this data was being highly used at the time of COVID, basically. The GIS AID data. Okay, great. So see here, let me show you this first. Okay, so this is the GIS AID data. Okay, the database. It has a very good number of sequence information of the different viruses. Okay, which you can make use of in order to extract and find out meaningful significance and analysis. Okay, then this is a very wonderful website, basically Gina browser database. Okay, it has done nothing unique is here. It has simply compiled a number of different data sets from the different websites. For example, TCGA and few other projects as well. Okay, so you can simply go here and explore this data set, having a number of different data sets. Okay, then we talk about the transcriptomic data, where we have gene expression omnibus, one of the biggest sources of transcriptome data, basically, right? So GEO, great. So GEO is being like it's one of the subdomain of NCBI, basically. So NCBI is the parent website hosting this particular GEO. Okay, and here you can search any particular disease and you will be able to search the dataset. For example, breast cancer. Okay, and then you will have a number of data sets against breast cancer in front of you. See, and whichever is your interest, just go and explore that. Okay, then you have clinical trials data. So you can go to like survival analysis. For survival analysis, SCER cancer database. So this is epidemiological data, basically, not survival, basically. So fine. Okay, so epidemiological data, you can go to SEER cancer database and then clinical trials.gov. Medical imaging data, you can go to TCIA. It has a very good number of image data sets, basically. The cancer image archive. Right, guys? So fine. So here you can go and explore a number of different type of the cancer related image data sets. Okay. Then population health studies. Framingham Heart Study. It is the data set about which I was talking about, right? So it is one of the world's biggest cohort prepared so far. Okay. Like in this, we have 3 generation of the population data available to us, right, guys? Then health informatics data. Mimic 3 clinical data. 3 clinical database is one of the world's biggest database, having a number of clinical information available to us, right guys? So these are just few of the example of the databases. Like this, we have more than 1,000 of the different databases hosting a number of data sets for us. Okay guys, and if you really want to do some kind of the analysis, in order to analyze these data sets and taking out meaningful informations analysis from there, you definitely need to have good understanding of statistics. And when we talk about statistics, the first concept of the data analysis starts with the field of descriptive statistics, where you will be given a data and you will be asked, what is the summary of the data? How is the different features distributed? What are the statistics of the different features? Right? So in the coming lectures, I will be talking about one by one the different metrics used in the domain of descriptive statistics. Okay, thank you so much guys for joining. Have a great time. See you.